Hello everybody, you are watching the channel Learn to Earn for Life.
Dear students, in this video we will discuss about the single phase AC circuits. We have the content in this video as analysis with phasor diagram of the circuits with resistor, inductor, with capacitor, with resistor and inductor, with resistor and capacitor, with series resistor, inductor and capacitor, and the different types of AC power. Let us go through the pure resistive circuit. Here resistor R is applied with the voltage of V is equals to Vm sin omega t, and let I be the current which is flowing into the resistor is called as I is equals to Im sin omega t. Here the voltage and current are in phase, and the power consumed in the circuit is P is equals to I square R, that is equals to V square by R is equals to Vi. And you can observe the phasor diagram that both the voltage and current are in phase, and it is also evident by the voltage waveform and the current waveform which is shown here. They are in phase. This is the power waveform. It is the product of V into I, and the average power is equals to Vm Im divided by 2 in a pure resistive circuit. Let us go through pure inductive circuit. Here the inductor is applied with the voltage source of V is equals to Vm sin omega t, and the current will be I is equals to Im sin omega t minus pi by 2. Here the current lags the voltage by 90 degree, and the inductor consumes zero power. Inductor stores the energy in the form of electromagnetic energy, whereas XL is the reactance of the inductance with unit in ohm. Here Im is equals to Vm by XL, where XL is 2 pi FL, or also it is represented by omega L. You can observe the phasor diagram that here the current is lagging the voltage by 90 degree, and it is also evident by this waveform. Here the voltage is starting at the 0 degrees, and the current waveform is starting at pi by 2. It means that it is lagging by pi by 2. This is the waveform for the power in a pure inductive circuit. Let's go through pure capacitive circuit. A pure capacitor is applied with the voltage of V is equals to Vm sin omega t, and the current I will flow will be equals to I is equals to Im sin omega t plus pi by 2. In a pure capacitor, current leads the voltage by 90 degree, and also the capacitor does not consume any power. It consumes zero power. Capacitor stores energy in the form of electromagnetics, where Xc is called as the reactance of the capacitor with unit as ohm. Here Im will be is equals to Vm by Xc, where Xc is 1 divided by 2 pi Fc is equals to 1 by omega c. And this phasor diagram shows that current is leading the voltage by 90 degree. This is also evident by this waveform that current is leading the voltage by 90 degree. This is the waveform for the power. Let us go through RL series circuit. Here a resistor and the inductors are connected in series, and this combination is applied with the voltage source of V, and current I will be flowing into the circuit. Here I is equals to V by Z, where Z is equals to square root of R square plus XL square. In RL circuit, current lags by 5 degree or radian, where phi is equals to tan inverse of XL by R, I is equals to Im sin omega t minus phi, and P is equals to Vi cos phi. Cos phi is the power factor of the circuit. Here Vr is the voltage across the resistor, VL is the voltage across the inductor, and here the current through these series elements as well as the voltage across the resistor are in phase, and the voltage across the inductor and the current through the inductor are 90 degree apart. It means that current lags the voltage across the inductor by 90 degree. If by the phasor addition, VR and VL will give me the voltage vector V, the supply voltage V, and this is the waveform of the for the circuit diagram, and this is the waveform for the power. Average power will be equals to VI cos phi. Let us go through RC series circuit. Here the resistor and the capacitor are connected in series, and this combination is applied with the voltage of V volts, and the current I will be flowing into this circuit, where I is equals to V by Z, where Z is equals to square root of R square plus XC square, and Z is called as the impedance with unit as ohm. Phi is equals to tan inverse of XC by R. I is equals to Im sin omega t plus phi. P is equals to Vi cos phi. And you can observe here the current through the circuit and the voltage across the resistor are in phase, and the current through resistor is leading the voltage across the capacitor by 90 degree. If we add the voltage across the resistor and the voltage across the capacitor, we will get the supply voltage phasor as V. In RC circuit, the current leads by 5 degree or radian. This is the waveform for the power. This is the waveform for the current. This is the waveform for the voltage. Here you can observe that the current leads the voltage by 5 degrees. Let us go through RLC series circuit. Here the resistor and the inductor and the capacitor are connected in series, and this combination is applied with the voltage of V volts. The current I will flow through these series of elements. Here I is equals to V by Z, where Z is equals to square root of R square plus XL plus or minus XC whole square. There are two possible cases in this RLC series circuit. If XL is greater than XC, the circuit behaves as a RL circuit. If XC is greater than XL, then circuit behaves as RC circuit. If XL is equals to XC, then circuit behaves as like a resistive circuit. Here phi is equals to tan inverse of XL plus or minus XC divided by R. I is equals to Im sin omega t plus phi, and P is equals to Vi cos phi. This plus or minus indicates as per based on these two points. When XL is greater than XC, the plus sign will appear. When XC is greater than XL, the minus sign will appear here. Let us go through the types of AC power. There are three different powers, that is, one is active power, another is a reactive power, and one more is apparent power. Let us check the active power. The expression for active power is Vi cos phi. Its unit is watts. The power which is actually consumed in the circuit is called as true power or active power. The expression for the reactive power is Q is equals to Vi sin phi. The unit of it is var. Here R stands for reactive. This is the component of the apparent power which is neither consumed nor does any useful work in the circuit is called as a reactive power. The expression for the apparent power is S is equals to V into I. Unit is equals to volt ampere. The total power that appears to be transferred between the source and the load is called as apparent power. Here the expression for the power factor is active power divided by apparent power by means of this power triangle. The power factor is the cosine of the angle between the voltage and the current. So active power is Vi cos phi based on this triangle, and the apparent power is Vi. Further, if we solve for it, it will be expressed as it can be also expressed as R by Z. Here R by Z will be cos phi. By impedance triangle it will be written as R by Z. By power triangle it will be written as active power divided by apparent power, which will be equals to cos phi. That is, it is the cosine of angle between the voltage and the current, that is adjacent side divided by hypotenuse. Thank you for watching the video.